America needs to produce 780 million pounds of plums annually to meet consumer demand. But traditional hand harvesting methods can't keep up, with workers averaging just 50 to 80 pounds per hour. The solution? A remarkable combination of advanced harvesting machines and precise processing technology that has transformed the industry. Modern tree shakers can harvest up to 10 million pounds per hour, while automated washing and sorting systems ensure only the highest quality fruit reaches consumers. This integration of technology has enabled American farmers to meet growing demand while maintaining strict quality standards. Today, I'll take you through each step of this impressive system that brings plums from California orchards to your local store, and show you exactly how they've solved the production challenge. How do farmers decide exactly when to harvest 780 million pounds of plums each year? The answer combines centuries-old knowledge with surprising new technology. California's Mediterranean climate creates ideal conditions for plum cultivation. The state's Central Valley, with its hot, dry summers and mild winters, allows plum trees to thrive across over 100,000 acres of specialized orchards. This unique growing environment gives California producers a significant advantage, enabling them to supply nearly 95% of America's commercial plum crop. Modern plum orchards are architectural marvels designed with precision. Trees are typically spaced 15 to 18 feet apart in rows separated by 20-foot lanes, dimensions carefully calculated to accommodate harvesting equipment while maximizing sunlight exposure. Pruning follows equally precise patterns, with trees trained into modified central leader systems that create strong scaffolding branches positioned at optimal heights for mechanical harvesters. Determining the perfect harvest moment involves multiple sensory checks. Experienced farmers assess skin color transitions from green to characteristic purple, red, or yellow depending on variety, applying gentle pressure to test for slight yielding that indicates proper ripeness. Sugar development is crucial. Most commercial varieties are harvested when Brix levels reach 12 to 14%, offering the ideal balance of sweetness and acidity. Digital monitoring has revolutionized this traditional process. Advanced orchards now deploy networks of IoT sensors that track microclimatic conditions throughout growing sites. These systems collect data on temperature variations, soil moisture levels, and even ethylene gas emissions from ripening fruit, creating predictive models that help farmers anticipate optimal harvest windows with unprecedented precision. California's diverse growing regions create a natural production schedule. Early harvests begin in the southern Imperial Valley, progressing northward through the San Joaquin and Sacramento valleys as the season advances. This geographic staging allows for continuous supply from May through October, with each microclimate contributing to the state's extended production calendar. Water management forms the backbone of successful production. Modern orchards utilize subsurface drip irrigation systems that deliver precise amounts of water directly to root zones. Computer-controlled emitters adjust flow rates based on soil moisture sensors, weather forecasts, and evapotranspiration data, reducing water usage by up to 30% compared to conventional methods, while supporting consistent fruit development. Soil preparation represents another technological advance. Before planting, fields undergo comprehensive analysis for pH, mineral content, and drainage characteristics. Based on these assessments, custom amendment programs address specific deficiencies, creating optimal growing conditions that support decades of production. Deep ripping eliminates hard pan layers, allowing roots to access moisture reserves during California's dry summers. The difficult balance between immediate productivity and long-term orchard health requires sophisticated decision-making. Farmers must weigh current market demands against tree stress factors, sometimes sacrificing maximum yields in a particular season to ensure continued production capacity. This calculus involves evaluating tree carbohydrate reserves, pest pressure, and projected weather patterns, decisions that impact profitability for years. Behind every perfect plum in your local grocery store, lies an engineering marvel few consumers ever witness. The tree shaker, a machine that functions like a giant mechanical hand, represents perhaps the most dramatic technological leap in modern plum agriculture, yet operates with surprising delicacy. Traditional harvesting methods created an impossible bottleneck in production. When limited to manual picking, workers could only harvest 50 to 80 pounds per hour, an insurmountable challenge for meeting national demand. This labor constraint threatened the industry's ability to scale until mechanical innovation arrived. The tree shaker's elegant engineering solves multiple problems simultaneously. Its specialized gripping mechanism clasps the trunk while generating precisely calibrated vibrations, strong enough to detach fully ripened fruit but gentle enough to leave leaves and branches undisturbed. This precision protects the tree's structure and preserves its productive capacity for future seasons. As plums detach, they descend onto an ingenious catching frame that unfolds beneath the tree canopy. This isn't simply a collection net, it's a sophisticated impact absorption system made from flexible materials specifically designed to prevent bruising. The frame's gradual slopes guide fruit toward a vacuum-assisted conveyor that begins the cleaning process immediately. For orchards with challenging terrain or wider canopies, the inverted umbrella canopy shaker offers an alternative approach. This specialized harvester vibrates the trunk while deploying an umbrella-shaped catching surface. Ripe plums slide down this carefully angled surface into an integrated conveyor system, maintaining fruit quality throughout the transit. The harvesting machines incorporate sophisticated cleaning technology directly in the field. Rotating brushes and air blowers remove dust, leaves, and debris before the fruit even leaves the orchard. This initial quality inspection eliminates unnecessary transportation of substandard fruit, improving overall efficiency. What truly distinguishes these machines is their astonishing productivity. A single modern harvester can process up to 10 million pounds of plums per hour, a transformation that allows entire orchards to be harvested in days rather than weeks. This speed is critical for capturing fruit at peak ripeness across vast acreage. The efficiency gains extend beyond just speed. By precisely controlling vibration frequency and amplitude, modern shakers can target specific ripeness levels, allowing for selective harvesting that was once only possible by hand. This technological precision has elevated mechanical harvesting from a mere labor replacement to a quality-enhancing innovation. Despite these remarkable machines, the plum industry hasn't completely abandoned traditional methods. In specialized situations, particularly for premium varieties or in terrain where machines simply cannot operate, human hands still provide irreplaceable skill and judgment. This creates an unexpected balance between cutting-edge technology and centuries-old harvesting traditions. This technological traditional balance isn't merely philosophical. It represents a calculated business decision that challenges economic expectations. Despite sophisticated mechanical harvesters transforming plum production, nearly 1/3 of American plums still feel the gentle touch of human hands, a deliberate choice that prioritizes quality over speed in specific market segments. The economics initially appear counterintuitive. Hand harvesting costs significantly more per pound and proceeds at a fraction of mechanical harvesting speeds. Yet for premium plum varieties, this investment translates directly into higher market prices that justify the additional expense. Specialty markets reward the perfect appearance, optimal ripeness, and unblemished quality that only selective human pickers can consistently provide. What truly sets hand harvesting apart is its unmatched selectivity. Unlike mechanical harvesters that collect all fruit at once, human workers can identify and pick only those plums that have reached perfect ripeness, leaving others to continue developing. This selective approach often requires multiple passes through the same orchard, with workers returning every few days to harvest newly ripened fruit, a level of precision impossible with current technology. Experienced pickers employ specialized techniques refined through generations of harvest knowledge. Their characteristic gentle twisting motion detaches plums without damaging stems, a critical factor in maintaining freshness and appearance. This attention to detail extends beyond just removing the fruit. It's about preserving quality from the moment the plum leaves the branch. After picking, the plums are carefully placed in soft-lined baskets to prevent bruising, preserving their fresh flavor, explains one industry report. This careful handling represents just the first stage of quality preservation that continues throughout the supply chain. The specialized containers prevent compression damage that would immediately reduce market value and shelf life. Beyond quality considerations, geography itself often dictates harvesting methods. Many premium plum varieties thrive in hillside microclimates, with steep terrains where mechanical harvesters simply cannot operate safely or effectively. These challenging landscapes make hand harvesting not just preferable but necessary, regardless of economic factors. Perhaps most surprisingly, hand harvesting actually protects the long-term health of orchards. While mechanical harvesters can damage branches and excessive leaf loss through vigorous shaking, careful hand picking preserves tree structure and foliage. This gentler approach helps maintain consistent production year after year, an investment in future harvests that adds another dimension to the cost-benefit analysis. The relationship between pickers and trees often transcends simple economics. Industry experts describe hand harvesting as more than just a job. It is a labor of love and dedication, reflecting the pride experienced workers take in selecting only the finest specimens. This human element, the judgment, care, and commitment to quality, remains impossible to replicate mechanically despite remarkable technological advances. That careful selection by human hands marks only the first step in a plum's remarkable journey. When stacked in bins at the processing facility, these fruits face a race against time. Fresh plums spoil within days, creating an urgent processing challenge few consumers ever consider. How to transform this highly perishable harvest into products that will last for months. The transformation begins with an automated cleaning process essential for maintaining quality. High-capacity washing systems employ precisely calibrated water pressure and soft brushes that remove dirt without damaging the delicate skins. This meticulous first step ensures each plum is perfectly clean before proceeding further down the processing line. For plums destined to become prunes, the next 24 hours prove critical. Workers carefully spread the freshly washed fruit across large industrial trays before placing them in specialized drying ovens. These temperature-controlled environments maintain a precise 104 to 105 degree Fahrenheit, warm enough to gradually evaporate moisture while preserving the fruit's naturally sweet flavor and developing that characteristic soft, chewy texture consumers expect. This controlled transformation represents one of food science's most elegant solutions to extending shelf life. After drying, the newly created prunes undergo a second wash to remove natural sugars released during the drying process. This additional cleaning step proves vital for maintaining the desired texture and appearance that consumers expect from the final product. Many prunes then enter the precision pitting stage. The process begins by gently steaming the fruit to increase pliability before feeding them into specialized machinery. High-precision rollers or blades then carefully remove pits while preserving the prune's shape, a delicate balance of mechanical precision that creates the pitted prunes found on store shelves. Quality control follows each processing step, with the final inspection proving particularly rigorous. Skilled workers assess each processed fruit for color, size, and uniformity, ensuring only those meeting strict standards continue to packaging. This human oversight remains irreplaceable, despite technological advances. While most consumers associate plums primarily with dried products, the processing infrastructure extends far beyond. Secondary processing creates an impressive diversity from a single harvest. Juices, jams, canned varieties, and specialty dried products for different market segments. This diversification maximizes harvest utilization while catering to varied consumer preferences and creating economic stability for producers. The journey from orchard to consumer creates products that transform what was once a seasonal delight into a year-round staple. This processing infrastructure represents a technological marvel that consumers rarely see, yet it depends upon, creating value from what would otherwise quickly perish. America's plum industry creates ripple effects throughout the economy, supporting vital sectors like transportation, packaging, and marketing. This agricultural powerhouse drives innovation in harvesting and processing equipment while bolstering rural communities where orchards and processing facilities operate. The industry's export activities generate valuable foreign revenue, enhancing the U.S. trade balance. Behind these impressive achievements stands the dedicated workforce of farmers, field laborers, and processing specialists who ensure quality at every stage. While not always visible, sustainability practices appear throughout production. From equipment designed to protect tree health, to processing methods that minimize waste by extending shelf life and maintaining stringent quality standards.